Okay. Okay, go ahead with the question about the lab.
So for part A, I guess I'm wondering about how you perform when you're trying to print out the values of the vectors that you declare with the constructor.
Okay, so you are trying to do what? Print it out now?
Yeah, you're trying to print out the names of the flights and the miles of the flights that are in the vector that you declared with the constructor.
Okay, so the question is, how do you print out essentially, how do you print out what you have in this flight vector? Because when you're done, you're going to have this, something that looks like this in your computer, okay? So you've used the constructor to create new objects and push those objects onto the vector. So when you come back, you might have a vector that looks like this, okay? Is that, okay. So all you need to do is write a for loop that iterates through the vector one element at a time. And I guess the way to think about a vector the way to think about a vector with objects is how sometimes you have containers that are lined up and you just start putting things in the containers, right? So think of, again, the idea of lockers that are numbered. So each time in the loop, you identify an index like 0 in the vector, it's just like saying, give me the contents of this locker, okay? Now, you have, in this case, the contents of the locker is an object. It's like I hand you an object now. Now you have to use that dot notation to get access to the member fields, okay? So you're going to use the same idiom to walk through let me bring up the notebook for a moment. Let me bring up a blank page. Okay, so you're still going to essentially have a for loop that looks like this for I equals 0, I less than the size of the vector. So I'm not going to give it away completely. So I less than the size of the vector. I plus plus. Okay, and then you're going to see out, and you have to see out some formatting information because we said that it has to be formatted. And then you need to output the flight name from the ith element of the vector. Okay, so now you output, okay, so see out flight name from ith entry in vector. And then it's the same thing, you output some more formatting information. And then you need to output the miles flown. Okay, so now, can you take it from there, or is it still not sure what to do? I guess the question is this part the part that is confusing you, that you're not sure?
Yeah, those terms is what I was, the for loop and everything is what being said, but like dot notations
Okay. Okay. So let's say that the vector was just a vector of integers. Okay. Let's just simplify it. So if it's a vector of integers, and I was asking you to output an element, you could just say something like, let's say the vector was named foo. You could just say foo I, correct? And that would output the integer. Okay? So with a vector of objects, foo of I gives you essentially an object. Okay, so when you say foo of I, it's like I hand you an object. And that object now has a name in this case and miles flown. So now what you have to do is you have to take it a step further and tell the computer which of the two member fields you want it to print. Okay? So that's where the dot notation comes in. So at this point, it knows that you'd like to print this object, but it doesn't have enough information. So you have to kind of guide it a little further. So foo of I gives you this object. Then when you say dot and name, it now says, I want to print the name field from this object. So foo of I is still returning an object. It's like saying, here's an object. But that's not enough. It now needs to know what you want to print from it. And so you use the dot notation to do that. Okay? So hopefully that's enough to kind of guide you through. Charles. Okay. So I understand this notation is can be a little bit, I don't know how to say it, complicated when you first start looking at it. So it may be one of those things you just have to memorize initially and say, okay, if I want to get a field name out of an object in the vector, this is kind of the idiom that I use. And as you repeat it and repeat it, eventually, hopefully, it'll become a little more understandable what's coming off. Okay. Other questions? Okay. So we started, I guess, to quick recap, we said structs were these things. Let me recap quickly. It's going to require that I open this. It's not what I want. Okay, so a struct allows us to store some related information. This is what a struct declaration looks like. It has the struct keyword, the name of the struct, and then a list of fields or member variables. The two terms are synonymous that give a list of the data we wish to store in that record. And it creates a new type called student. So now I can declare a variable to be a student, just as I would declare one to be an int or a vector. I just say, okay, it's student. And wait just a sec, John, or Charles. So if I want to assign a value to a field in the record, I use dot notation to navigate to the appropriate field. Because I can't just say ST equals John. That's not enough information anymore. It needs to know the field that I want to assign the value to. So you give the name of the variable, but then on top of that, you need to give the name of the member variable. So you use this dot notation to give the name of the field. Yes?
Do we not have to do the student ST thing in this lab?
So in
That
So what do you mean using a constructor? So you're thinking that I have to include some parentheses here with some initialization? Not always. It depends on how the constructors have been declared. Okay? So we'll get to it, but there's the constructors basically, think of them a little bit like factories. The constructors define how you build the object, okay? So some constructors take no arguments, and if a constructor takes no arguments, then you don't have to provide any arguments here. In the lab, we forced you to declare a single constructor with 2 arguments. So in effect, we only gave you one factory, and that factory says you have to give us 2 arguments when you create the object. So in that case, you had to provide 2 arguments. So think of it like an automobile factory, okay? When you try to order a car, well, you may not have done it yet, but you sometimes just have to take it the way the dealership gives it to you. You can't really order it in a special way. And it's kind of a bit like that with creating structs. Depending on the way we set up our so-called constructor factories, we are constrained in how we can create an object. In this case, I was assuming correctly because here there's no constructor. And so as we'll discuss today, when you don't provide a constructor, the C++ compiler builds one for you that takes 0 arguments. So in this case, with no constructor declared, the compiler builds a default one for you that is a 0 argument. Therefore, you don't need any arguments here in this case. Yes. Okay. Other questions about structs? Okay, that's the quick 5-minute review of them. So then, a big thing with when you declare a struct variable, you may want to initialize it. Okay, so up to now, you've seen different ways to initialize things. So if it was a int variable, here, let's do it over here. So with what we call primitive types, like say int, you could say int miles equals 10. Okay? If you want to initialize an array, let's say int weights, does anyone remember how you can initialize an array? Curly braces, very good. So you could say something like 5, 15, 8, 7. So that was how you initialized arrays. Okay. With vectors, we said it's very uncommon that you would do this because you really shouldn't be using a vector if you know how many elements it has, but you could say vector int weights, say 10, 5, and this would be the initial value assigned to all entries. So the question then might become, how can you initialize the member fields of a struct? And the answer is you use something called constructors. And as I just said, you might think of a constructor a little bit like you'd think of a factory. It takes some inputs and it builds your object and then puts it out. So like with a car, you know, it might be I want a red car with leather seats and dual AC controls. So those are the things I want. Goes into the factory. It comes out with those things installed. So you can think of a constructor in somewhat the same way. It takes some desired initial values for the member fields, assigns those values to the member fields, and hands you back an object with those member fields initialized. Now, as I just said to Charles, you are constrained in how you can create the object. And the way you are constrained is that you can only create objects according to the constructors that have been declared for it. So the way you declare constructors is they are placed in the struct along with the member variables, and please don't mix them. For example, put all the variables first and then put your functions, or put all the functions first and then put the variables, one or the other. In a struct, you typically only put constructor functions. You don't put any kinds of other functions in there. And the constructor function has a very specific way to declare it. Okay? Does anyone remember there are two things that make a constructor a constructor? Okay? Two things that are unique to constructors. So what two things make a constructor a constructor? Or let's say, tell the compiler. That this function is a constructor. Okay, there are two things. Same what? Same name as the struct, okay? And no return type, very good. Not even a void. Okay, so no return type, not even a void. Those two characteristics set a constructor apart from any other kind of function. In the struct, you only provide the function prototype. You do not provide the function definition. The function definition goes after main, just like all of your other function definitions. So in the constructor declaration, you only provide declarations. And just like any other function, you do provide the set of parameters to it. These are presumably the values that you're going to use to initialize this struct with. The second part of it then is once you have declared a function prototype in the struct, you're going to have to put a function definition after main. And it's not enough to simply write it as come on, delete. Uh-oh. Nice little rain. There we go. Okay, so you can't just specify it that way. If you do, it will not be associated with the student struct. You might think that's kind of stupid, but the compiler's not a particularly bright individual. Okay? So in order to tell it that it is associated with the student struct, you have to prefix the function with student colon colon. So the name of the struct and then colon colon. If you don't do that, you're going to get an odd message from the compiler telling you that it doesn't recognize this function. Okay? And then inside the constructor body, you just do your initialization. So name, major, and GPA are all variables declared in the struct. So notice I don't have any declarations for name, major, and GPA in the constructor, right? That's kind of odd. We haven't done that up to now. Up till now, inside a function, if you used a variable, it had to be declared either as a parameter or as a local variable. This is different. The reason I don't have to do it is because name, major, and GPA are declared in the student struct, and since this constructor is associated with the student struct, it knows about name, major, and GPA. Okay, so this is how we initialize the fields of a struct. Questions about this? Okay. Now, you can use a constructor in multiple ways. A constructor, remember, essentially is manufacturing an object for us. It's like a factory. So whenever we need to manufacture an object, we can use it. Okay? One time when we may want to manufacture an object is when we declare the variable, and then we may want to assign it some initial values. So that's one time. A second time is when we want to create an object in order to pass it to a function such as pushback, which is what you're doing in Lab 10, is you want to manufacture objects, in this case flight objects and flyer objects, which you then want to push onto a vector. So you can use a constructor in that situation. You call the constructor function, like I'm doing here. You pass it the values you want the object to initialize, and just like ordering a car, it says, okay, I'm going to create a student object named John with these features, and then it returns the object, and that object is now, in this case, being given to pushback, which will add it to this vector. And you're doing the same thing in Lab 10, except you're doing it with flights and with frequent flyers. There, you're manufacturing flights objects. In part A, you manufacture a flight object, and then you have to add it to a flight vector. Then later in Lab 10, when you get to parts B and C, you'll need to, well, actually part B, when you start to register flyers, each time you register a new flyer, you will need to manufacture a flyer object and add it to the frequent flyers vector. Okay? So you can kind of think of it as what's going on here is we call student John, and what happens is the compiler, so we'll call it student factory, so student constructor, but we'll say it's a factory. Okay, manufactures a new student object with the desired values. Okay, so out pops a new student object with name John Let's make it bigger. And address, I can't get it all in, so I'll just say 1678 ... and GPA 4.0. So it's manufactured this student object. Okay, now the student object is getting passed in the pushback function. Okay, and pushback adds the student object to the vector. So when we're done, we have name, John. We have address. Again, I don't have room to completely write it out, 1678. And we have GPA 4.0. So that's kind of what is going on here with this statement. Okay, and this is, of course, student list. So the first thing is it calls the student constructor. Sits there, it works, manufactures a student object, which it then pushes out. Okay, we have a brand new student object comes rolling out of the factory. Okay, now that object is given to pushback. So it's handed over to pushback. Pushback takes it. It's got the object in its hands, and it adds it to student list. Puts it onto the end. Okay, so takes it and adds it to the end of student list. So when we're done, there's a new entry appended to the end of student list. Okay? So is that, yes? Yes. Thank you. There should be another parentheses right there. You are absolutely correct. Other questions about this? Okay, so hopefully giving it that kind of analogy will help you visualize what's going on under the covers, so to speak. Okay? Other questions about this process? Okay. So, what happens if we don't provide a constructor function? Okay. That's legal. I didn't do it early on. Here, I provided, whoops, not here. Here. So there was no constructor in this struct. Okay, that's perfectly okay. In that case, the compiler manufactures a constructor for you. It builds a factory, and this so-called constructor factory takes no arguments, and it does nothing. We call it a stub function because it simply leaves the member variables uninitialized. So if you were to look at what it looks like, its function definition, it would look like this. Student, student, takes no parameters, an empty pair of curly braces to indicate it does nothing. That is the default constructor that the compiler manufactures for you. So all the member variables are left uninitialized. You don't know what their values are. Now, this point is critically important. As soon as the programmer defines a constructor, the default constructor dies. That is, the compiler is lazy. It only builds a constructor for you if you don't provide one. If you provide a constructor, it will not provide one for you. So if you're willing to build your own factories, it's more than happy to let you do so. Okay? It won't build anything for you if you already do the building. This is something that causes a lot of confusion at the beginning because it seems that a lot of you somehow assume that the compiler is a giving compiler, a kind compiler that is building constructors for you even as you do. It doesn't. It's mean. Okay? Once you build a constructor, it says, I'll go on and do something else. So it does not provide a default constructor if you create your own constructor. What that means is that if you want to, let's see, do this my next slide, yes. If you provide a constructor and now you want there to be a zero argument constructor, you must explicitly declare one. So we are allowed to create multiple constructors. You know, hey, most big companies have multiple factories, right? GM doesn't just have one factory, it has many factories. And you might say, well, GM has a lot of different cars. That's true, but GM frequently manufactures the same car at multiple factories. So why can't we have multiple factories? The answer is there's no reason we can't. So we're allowed to create multiple constructors. They all have the same name, the name of the struct. They all have no return type. And they initialize the struct in different ways. So each of them you provide a function definition for. I mean, presumably, this first one either leaves the variables uninitialized or initializes them to default values. So maybe a student coming in with zero arguments, you might set the name to an empty string, the major to, say, undeclared, and the GPA to whatever, 0.0 initially. If it comes in with a string, maybe this is an undeclared major. So perhaps this one is for an undeclared major. So this one, when you define it, you might say name equals n, major equals undeclared or undecided. Say undecided. And the GPA is 0.0. Okay, maybe this one is for a transfer student. The student is already transferring in some courses, already comes in with a GPA. So this one, I'm not going to go through it, but you've already seen it, where you declare where you assign each of those parameters to the appropriate field in the struct. So this might be for a new student. This might be for a transfer student. Okay, and this one, I'm not going to give a lot of particulars, but this might be just for temporary variables. Sometimes you just need to work with scratch storage. Okay, so in that case, you want to be able to create a student object for scratch storage. Like if I need to swap, remember with swap earlier in the semester, we needed temporary variables, so sometimes you just need temporary variables. In that case, you don't need to initialize it to anything. Okay, But the important thing then for this slide, the takeaway message for this slide is right here. Is that the constructors constrain how you declare the variable. You need to declare the variable so that it matches the pattern for one of these three constructor methods in this case. So your way you declare a variable must match the pattern of one of its constructors. So if I don't provide, so let's say in particular, no, I don't have it, so let's go to the notebook again. Let's say that in struct student, I have some field declarations, which I'm not going to enumerate. And then I have one that looks like student string n string major and int, or double rather, G for GPA. And there's a semicolon there. And let's say that I now try to declare a student like this. This is an error. It's an error because the declaration does not match any of the constructors that I specified in the struct. In this case, the only constructor I specified was this one, and this one requires 3 arguments. Therefore, the only legal declaration is going to be one that provides 3 arguments. Again, there is no default 0 argument constructor in this case. Okay, so I'll actually say no 0 argument default constructor exists. Okay, yes, Charles.
So S is just one instance of that.
Yes, it's just one instance of the object. Other questions? Okay. Okay, so let's go on to here. So again, a 0 argument constructor is one that has no arguments, and it is special in that it has an unusual and inconsistent way of declaring a variable. So you would think, based on everything you've seen up till now in the course, that this is how you should declare a student that is calling the 0 argument constructor, right? Because up until now, anytime you called a 0 argument function, you still had to provide a pair of empty parentheses. But in the special case where you are calling the 0 argument constructor, you do not provide parentheses. So this is how you would declare a student if you wanted to call the 0 argument constructor. There is a reason behind the C++'s inconsistency, and it goes back to the fact that the compiler is pretty dumb. Okay? If it sees this particular kind of declaration, this declaration matches something that you have already seen earlier in this course. It's a function prototype. This looks like a function, okay, so to the compiler, this declaration looks like a function prototype. That is declaring a function named st that takes 0 arguments and returns a student object. The compiler, not being particularly bright, is simply, it's just matching patterns. Okay, that's all it's doing, it's matching patterns. That pattern looks like a function prototype to it. You might think that in context it could figure out that this should be a variable declaration. No such luck. It's dumb. It just looks at the pattern and says, wow, I know what that is. That's a function prototype. So it doesn't do what you want. Therefore, you have to use that way of declaring a variable when you're invoking the 0 argument constructor. Okay? Any questions about that? Okay. This just quickly, I don't expect you to remember this right now. So if you want to take a moment and check out, that's fine. There is a simpler way to initialize variables, and C++ gives us a shorthand way, which is after the parameter list, you can put a colon and then a comma-separated list of name parameter pairs. And you use parentheses to make the assignment. So in this case, N is being assigned to name, Maj is being assigned to major, grade point average is being assigned to GPA. And then an empty pair of curly braces that does nothing more. I am totally fine with you using this way of creating constructors. I am totally fine with you using the other way of creating constructors. In CS140, you will find out that this is the preferred way to create an object because it turns out, for technical reasons that I'm not going to get into, that this way is more efficient. So technically speaking, this is the preferred way. However, it's just beyond the scope of this course to get into why this is more efficient, and therefore I'm telling you I don't care which of the 2 ways you do it. Okay, so got some clicker exercises for you. Whoops, got some questions first. There are no good question. The question was, are there really no semicolons missing here? And the answer is, there are, in fact, no semicolons whatsoever required. It's just, the reason is, a semicolon is a delimiter, like a period that ends a sentence. In this case, the appearance of a curly brace lets it know that it's the end. So, okay. So fire up your clickers. Okay, so give that one a try. What is what? Is 26 not working? Yet? Wait. Yours is working? Okay. Sounds like yours may not be working. 26 works, but it's not responding for you? It's working? Okay. Okay, so I'm going to give you 5, 4, 3, 2, 1, 0. Very good. If it's a 0 argument, it does not take any parentheses. For those of you who answered 2, copy this slide down. That is why 2 is wrong. Because to the compiler, number 2 looks like a function prototype. So if you got that problem wrong, you did not happen to take a picture of that slide or did not write it down because that is why answer number 2 is incorrect. Okay? Is that clear? I mean, if you don't understand why, I'd really want to know why. Okay. So moving on. And I don't have a question for this slide, so we're going to go on to the next one. Okay. Okay, going to give you 5, 4, 3, 2, 1, 0. Very good. So there is no 0 argument constructor declared. If you look up there, there are 2 constructors declared, one that takes 1 argument and one that takes 2 arguments. Okay, so those of you who answered 1 are thinking, well, what about the default 0 argument constructor? That slide covers that situation. If the programmer defines a constructor, the default constructor dies, meaning the compiler is lazy and it won't construct one for you. It only constructs a constructor if you don't provide any. So this slide covers why number 1 is incorrect. The default constructor does not exist when the programmer provides a set of constructors. Yes?
In order to make it correct, you just put
Yes, so the question was, in order to make it correct, could you put parentheses after the P and some kind of string? And the answer is yes. So if I had said person P, Brad, now that matches the one argument constructor up there, and it would be more than happy. Other questions? Okay. Give that one a try. Okay, I'm going to give you 5, 4, 3, 2, 1, 0. Okay, we had a pretty big split there between 1 and 3, and that doesn't surprise me. So the good news is that 100% of you knew that the name of the constructor was the same as the name of the struct and that it had no return type, so you didn't choose 2 or 4. Now, bad news is you're confused about when to use the colon. Inside the struct, so this is inside the struct where you're declaring the constructor, do not use the double colon. Inside the struct, it already knows that because it's inside the struct, it's in context. So you don't need to use the double colon inside of the struct. It kind of knows from the fact that it's grouped with the struct that it is part of it. You use the colon notation when you define the function definition. Okay, remember earlier we said we were going to be very careful in this class to distinguish between a function declaration and a function definition. And we're not going to write trick questions on it. So a function declaration is simply when you declare it. So it's the function prototype. Whereas the function definition is the function's body. Okay, where you declare you only use the colon notation with a function definition because the function definition is outside of the struct. And because it's outside the struct, the compiler is not able to place it with the license struct. And in that case, when you make the function definition, you're going to have to use license colon in order to associate it with the license struct. So inside the struct, the colon notation is unnecessary. Does that make sense? So with a function declaration, do not use colon notation. Okay, with the function definition, do use the colon notation. Okay? Questions about that? Okay. Give this one a try. By the way, I can't spell license on number 3. That's not disqualified because I can't spell. That second C should be an S. Okay, going to give you 5, 4, 3, 2, 1, 0. That's outstanding. Very, very well done. So you always must call the constructor in order to create an object. That's why 2 is correct and 4 is not correct. You have to give the name of the constructor when you create an object. It's like you have to designate the factory explicitly. Okay? So that's just the key to that one, is that when you want to create an object, you have to give the name of the constructor. You have to tell it what function you're calling. Okay? For does not call a function. In fact, what for does is it's trying to pass 2 arguments, 10 and smiley, to pushback. And pushback doesn't take 2 arguments, it only takes 1. So you get an error message. Okay? So we good? Any questions about constructors? Yes.
I noticed that you always usually capitalize the first letter of your structs. Is that
That's convention. It's not required. So the question is, I noticed that you're always using a capital letter as the first letter of a struct name. And the question is that required? The answer is no, but it's conventional. Therefore, strongly urge you to get in the habit of capitalizing the first letter of a struct or a class. It's just a way to help a human reader identify it. Just like we ask that when you define global constants, you make them all capital letters. The compiler doesn't care, but to a human reader, it makes it at a glance clear what your intent is. Other questions about structs, about constructors? Yes. So, right, so what you're saying is if here I had no arguments, so if, let me make sure I understand what you're saying. So, whoops. Okay. So if you're saying if I had a so I'm going to set up the scenario. If I'm wrong, let me know. So if your question is, if you have a 0 argument constructor, is this called legal? The answer is yes. Okay, this is adding an object to state licenses, and that is a legal call. But I don't know, is that your question or is it not your question? Okay. Okay, so the other constructor. So you want me to go back to a student constructor? Did you want me to go back? Mm-hmm. You mean, okay, so you're saying what if I had another, whoops.
No, on
No.
your struct where it says it has no member variables, like where do those arguments go?
Oh, I see. So this was just a partial one, I guess. I was only, to save space, I wasn't putting the variables here. That's why, I'm sorry. So I said I have the following partial, because I didn't have room. Probably I should put dot, dot, dot there to make it clear that there was more to it than just that. Okay, sorry.
So you have to have member variables then whenever you have a structure.
Yeah, there's no real reason to create a struct without member variables. I guess theoretically you could have one like that, but there would be no reason for it. So the only reason, yeah, would be to have a struct with member variables. So that will change with classes. When we get to classes, that's a different can of worms, so to speak. Okay. Other questions? Okay. Take a deep breath. That was structs. Remember how I said that vectors were the luxury version of arrays? We're now going to move on to the luxury version of structs, which are called classes. Okay? We're going to only touch on them briefly today. You don't need them for this is wrong. You don't need them for the lab, but we need to start getting into them. So we actually encountered them briefly back, remember Star Wars, a long, long time ago? So a long, long time ago in a galaxy far, far away, we talked about stream objects. And at that time, we briefly said that there are these exotic beasts in C++ called classes. Well, turns out classes are beefed up structures. Okay? And a structure basically is just keeping track of, is record keeping. A struct just keeps track of a record. Like in lab 10, we need to keep track of flight information, or we need to keep track of frequent flyer information. But sometimes we want to do more than just do record keeping. We want our objects to have real actions associated with them. So back then, the example I gave was an alarm clock. Let's say we want to simulate an alarm clock. Well, an alarm clock does more than just keep the time or an alarm or what the temperature is. An alarm clock wants to display that information, and the alarm clock also wants to give you ways to change that information. Okay? So we want to be able to model that situation in C++, where not only do we keep information in a struct, but we can also manipulate it. And the way we are going to manipulate it is to use functions. So classes are going to be structs where not only can we have fields, but we can have functions also in the struct. Okay? So we have the idea of keeping information, which is what structs do. But on top of that, we are going to add what are called member functions to classes. So now we can use these member functions to manipulate what we call the state information of the object. And the member functions, which we call methods, so you'll hear me use those two terms interchangeably, allow you to do two primary things. One is query the state information, okay, because we'd like to be able to know what the current time is, what the current date is. They also allow us to change the state information, to change the hour, to change whether it's AM or PM. Okay? So those are the two main things that our member functions are doing. They're querying the state information, they're changing the state information. Okay? So a struct and a class both declare what we call a blueprint. Remember I talked about factories, constructors as factories. What they're working off of is a blueprint, right? When we want to construct things, we take a blueprint, and then we use the blueprint to construct objects. So structs and C++ declarations are like blueprints that lay out for the compiler how to put together an object. So a class, like a struct, is allowed to have member variables. But in addition, it also can have member functions. Now, structs were allowed to have constructors, but we go a step further and allow C++ classes to have member functions. Okay, so this is kind of relating stuff we've already talked about. Classes and structs are types. They are blueprints. Then variables contain instances of those types, which are called objects. Okay, so an object is called an instance of a class or a struct. So an object is what is manufactured. The class declaration and the struct declaration is a blueprint that tells the compiler how to create the object. The constructor, in some sense, then is the factory that manufactures it, that realizes it, and the resulting product is the object. Okay, so you can think of a, if you want to, good analogy, a class or struct declaration is a blueprint, like a blueprint. Okay, so a constructor, you can think of it as a factory that takes the blueprint and a set of initial and constructs an object. Okay, then an object or a variable, we'll say a variable, stores an object that is produced by a constructor. So class struct declaration is a blueprint. The constructor is like a factory that manufactures an object. The product is an object. A nice new gleaming object rolls out of the constructor factory, and then we can store it in a variable. We set the variable equal to that object, and the variable stores that object. Okay, and with a class, that object comes with some functions that you can use to manipulate it. So a vector is actually an object that comes with a method called pushback and another method called size that allows you to, size is a query method. Size allows you to query the number of elements in the vector. Pushback is a modifying member function. It adds an object or an element to the vector. So a vector is an object with some nice functions that do things for you. Okay, we will pick up this discussion on Tuesday and continue it next Thursday. I'll also be posting this video of this lecture to the Google site later today.